This is going to be the last lesson for our review unit for pre-calculus. We're going to be talking about matrix operations, which is going to be really useful because, we talked in our last lesson about systems, and later on you may have seen already in Algebra 2, and if not, either way, we're going to talk about ways to solve systems using matrices and all kinds of cool stuff. So we want to make sure you have the basics of how to deal with a matrix. Now, so what is a matrix for the newbies and the whatever bees and all the things? So a matrix is a row column structure in math. The formal definition in the that makes sense from programming back in the recesses of my brain. So it's a rectangular array of numbers or letters or expressions or whatever. So an example of a matrix might be this one. We could have a matrix like this. -2, 3, 8, 0. Sure. Just put random numbers. So this is an example of a matrix. Another example of a matrix would be this. Another example of a matrix might be something like this. That's totally a legal matrix. Now, the way we talk about the size of a matrix is we describe it as row by column. So this one right here would be a 2 by 4 matrix, 2 rows by 4 columns. This one right here would be a 2 by 1 matrix. And then this last one would be a 1 by 1 matrix, right? So that's kind of how we size matrices and all of those things. Now we're gonna do some operations with matrices. Remember, from back a long time ago up to now, operations are things like add, subtract, multiply, divide. Those are all operations, right? So let's talk about adding and subtracting matrices. So adding and subtracting. Tracting. Now, so for adding and subtracting, it's ugly, but you get the point across. We got the point across, right? For adding and subtracting matrices, they have to be the same size. Must be the same size. Same size. This is muy importante, right? So you cannot add a 2 by 3 matrix plus a 2 by 4 matrix. They have to be the exact same size in order to add them. So we're going to jump in and look at an example. Example number uno. Example 1. If we have the matrix A as this matrix, 8, 3, -5, 14. So this is a square 2 by 2 matrix. So this one is, for our B, we're going to make it B 12, -7, 6, -23. So we want to find A plus B. Now you notice, if this happens to be the first time you've seen matrices, that we label matrices with capital letters, right? So matrix A, matrix B, that's typically how we do that with those things. So we're going to find A plus B. And so the way you do that is you add it element-wise. So we would add, in this example, we would add, for this first part, 8 plus 12. And then for the second one, we would add 3 plus -7. All right, so 3 plus -7. And then this next part would be -5 plus 6. And then this last one would be 14 plus negative 23. Then we'd, of course, do that. So 8 plus 12 is 20. 3 plus negative 7 is negative 4. Negative 5 plus 6 is 1. 14 plus negative 23 will be 6 plus 3 is 9 plus it's 19, right? Oh, yeah. How about negative 9, not 19? It never hurts to sanity check, whether it's checking what somebody else got or using a calculator or some other thing. So that is the first example, adding and subtracting matrices. Let's look at the next example, example number 2. Example 2 is going to be multiplying by a scalar. Okay, so for this one, we're going to evaluate. Every time I look at the word and say the word out loud, scalar, it's probably my Texas accent, scalar. I always want to put an E right there, but scalar, I don't know. You figure it out. Pronunciation. I've only ever lived in Texas, and I've only ever heard the word pronounced scalar, but that seems... Anyway, here we go. Here's our example. So what is a scalar? A scalar is this is an oversimplification maybe, because a scalar doesn't necessarily have to be a number, but a scalar in this context is just a number, right? So we're going to multiply 3 times the matrix negative 6, negative 3, 7, 10, 2, negative 15. Now, even if this is your first time seeing multiplying a matrix by a scalar, you could probably guess what to do, because at this point we've seen a lot of things that kind of vaguely work out similar to this, because you essentially distribute it. Now I'm going to write out it all, the intermediate step of actually writing it all out for notes purposes. You could probably just do 3 times 6 is negative 18, 3 times negative 3, and just go from this straight to the answer at this point in your thing. But for note's sake, I'm going to go ahead and write it all the way out. But we essentially distribute it. Multiply 3 times every element in that matrix. Okay? So it ends up being 3 times negative 6, and then 3 times negative 3, and then 3 times 7, and then 3 times 10. Excuse me. My goodness. 3 times 2, and then 3 times negative 15, right? So then you'd, of course, do that. Again, you could probably do those bits in your head, and that would be totally fine. But here it is. 3 times negative 6 is, as I said a minute ago, excuse me, negative 18. Negative 18. 3 times negative 3 is negative 9. 3 times 7 is 21. 3 times 10 is 30. 3 times 2 is 6. 3 times negative 15 is negative 30. There we go. Easy peasy lemon squeezy. So we're gonna do another couple of examples, kind of with multiple steps in a row. I'm going to pause for just a second. I'll be right back. It is 5,000 degrees in here. I need it to not be. I'll be right back. Okay, so here is the penultimate example of this video. We're going to do a little kind of multi-step operations, and then we're going to do a matrix equation, and then this lesson and unit are through. So this guy, now there's actually a couple of different methods to do this, but the way we're going to go about doing it is we're going to use the distributive property. We're going to distribute that 4 in here. So we've got a scalar multiplied times a couple of different matrices, right? So we've got 4 times 3, 8, negative 2, negative 5, 5, negative 4. plus 4 times, excuse me, times negative 4, 5, 7, 3, negative 10, negative 6. So then we multiply those scalars out. So we end up with 4 times 3 is 12. Probably did that a little crazy fine. Probably needed a little bit bigger. 12. 4 times 8 is 32. 4 times negative 2 is negative 8. 4 times negative 5 is negative 20. 4 times 5 is 20. 4 times negative 4 is negative 16. Bring down the plus. And then 4 times negative 4, excuse me, is negative 16. 4 times 5 is 20. 4 times 7 is 28. 4 times 3 is 12. 4 times negative 10 is negative 40. 4 times negative 6 is negative 24. So now we just add them up component-wise. 12 plus negative 16 is negative 4. 32 plus 20 is 52. Negative 8 plus 20 is positive. Excuse me. I jumped the gun. Gave you a spoiler. Sorry, ruined your life. Negative 8 plus 28 is 20. Sometimes my brain and mouth and hands all move out of sync. It's kind of a little bit infuriating. Negative 20 plus 12 is negative 8. 20 plus negative 40 is negative 20. Negative 16 plus negative 24 is negative 40. Okay. And there we go. Let's do one more example. We're going to solve an equation. The equation that we are going to solve is 4 times x. X is a capital X, and that is intentional because our answer is going to be a matrix. 4x minus b equals a. And we are going to solve for x if a equals negative 9, 15, 4, and 2, negative 10, negative 5, and b equals 5, negative 7, 8, and 14, 10, and negative 3. So you could just plug these entire matrices in here and then solve for x with it all chucked in there. But it's going to be easier if we do a little bit of just straight up regular good old-fashioned algebra on this first and solve this equation for x. Okay, so to solve this for x, we got to get rid of this b. So to get rid of the b, we would add b to both sides. So plus b. So these cancel, leaving us with 4 times x equals a plus b. Now to get rid of this 4, you're dividing by 4. Now I'm going to write this a little bit different because it's going to be a little bit easier to think about this because of distributive property. If we think about it as multiplying this times 1/4 instead of as dividing by 4, because of course multiplying by 1/4 is the same. And they're both correct. It's just easier with a matrix to understand it as multiplying times a scalar. It's the same thing, really. Multiply that times 1/4. These cancel. Now I'm going to go one step further, and I'm going to go ahead and distribute that 1/4 into this thing. And then we've got an expression kind of like the last example where we're going to just plug the matrices in and then just piece it out one step at a time. So x equals 1/4 times a plus 1/4 times b. Now we know a and we know b. We can substitute those matrices in there. So x equals 1/4 times -9, 15, 4, 2, -10, -5, plus, right? Yes, plus 1/4 times 5, -7, 8, 14, 10, -3. Now, I would, and I am going to, when I multiply these scalars out, I'm going to leave that denominator on there, and we'll kind of keep an eye on how it's going to look, because when you add fractions, which is what we're going to do next, right? We're going to add it. You need a common denominator anyway. So that's what I'm going to do. So I'm going to distribute this 1/4 in there, but I'm going to leave it just as an improper fraction. And I'm not actually even going to reduce it until the end, because it's just going to be easier to walk through, right? So this would be -9/4, 15/4, 4/4. This one looks like it's going to reduce. With that one too, but I'm going to leave it for now just so I don't get confused, and I kind of sanity check myself correctly. And then 2/4, -10/4, -5/4, right? Plus 5/4, -7/4, 8/4, 14/4, 10/4, and -3/4. Now we're going to add this up component wise, and this time I may take the reduction in one more step, just because if I'm going to make a mistake, it'll be live record. Well, not live, but while I'm recording a video. So -9/4 plus 5/4 would be -4/4. That reduces. We'll deal with that in a minute. 15/4 plus -7/4 would be +8/4. That also reduces. -9/4 plus 8/4 is -1/4. That does not, in fact, reduce. That one's just going to stay the way it is. Have I done something wrong? This does not match what's right there. 9, 15, 4, 2, -10, -5, not -9/4, 15/4, 4/4, 2/4, -10/4, -5/4, 5/4, -7, 8/4, 14/4, 10/4, -3/4, 4. Oh, I did it. What did I even did? I was looking at the wrong. Oh, I see what I did, actually. Yay. Caught my mistake. 4/4 plus 8/4, which is what I should have been doing, is positive. Oops. Positive 12/4, which does in fact reduce. 2/4 plus 14/4 is 16/4. -10/4 plus 10/4 is 0. That one's nice. That one does not reduce. It's as reduced as it can be. -5/4 plus -3/4 is -8/4. fourth. So finally, we're going to reduce this guy out. I'm going to write it over here because that's the easiest space for me. My final answer, our final answer would be negative 1, 2, 3, 4, 0, negative 2. All right, there is our review of matrix operations. In the next lesson, we are going to start Unit 1 of the actual factual, real life, no joke pre-calculus. We will see you then if you're one of my students. I look forward to seeing you in class. Do your homework, all the things. Ask questions on Discord, all the deals that are going on. If you're not one of my students, I hope this was helpful to you. And whoever you are, don't forget to like this video, hit that subscribe button, and let us know in the comments how we can help you with math, science, or general homeschool knowledge. Adios. Bye-bye.